وهاي الجلسة فيها 4 أوراق راح تحكي كل موضوع فيه والمتجددة وتطبيقاتها وفرص الاستثمار. كل موضوع فيهم هو موضوع بحد ذاته موضوع للبحث. فأول شيء بدنا نرحب مع بعض بالدكتور محمود صالح إسماعيل. الدكتور صالح محمود إسماعيل هو أستاذ مساعد في كلية الهندسة في خطوري، وهو حاصل على شهادة البكالوريوس من الجامعة الأردنية بعمان، وحاصل على شهادة الماجستير بالكلين انرجي والانرجي كونزرفيشن من جامعة النجاح، وحاصل على شهادة الدكتوراه بالهندسة الإلكترونية من ماليزيا بالرينيوبل انرجي من جامعة ماليزيا. تفضل دكتور، معك المفروض معك 20 دقيقة. بس معك 20 دقيقة، بس بدنا نعطيهم مجال للأسئلة، فيا ريت تكون تعطيهم 5 دقائق على الأقل بالأحد. ماشي، بس احنا عشان اصلا متاخرين في كل شيء فنحاول نلحق الغداء لانه الناس عندهم مهم الغداء.
مشكورة دكتورة صفاء. السلام عليكم، بسم الله الرحمن الرحيم، مساء الخير للجميع. عنوان هذه الورقة اللي قدمت لهذا المؤتمر Feasibility of using microturbines instead of diesel generators as backup sources in PV wind hybrid energy systems. كان هدف هذا البيبر هو analyze different configurations of hybrid systems, and the purpose, the objective, is to find the optimal sizes of each of components constructing the hybrid system in order to minimize the cost of energy production. The following will be covered in this presentation: an introduction, problem statement, hybrid system modeling, methodology and modeling, simulation inputs, energy management strategy, and simulation results and conclusions. As you know that most of the energy comes to the Palestine comes from external sources. About 80% comes from external sources. And this applies also for electricity. For electricity, about 93% of the electrical supplies comes from external sources, from Israel, from Jordan, and from Egypt. Furthermore, about 35% of the Palestinian houses receive an interrupted electrical power source. Furthermore, that many remote small communities in Palestine are still without electricity supply. So, the need for a clean and more secure supply of electrical power arises. The Palestinian Energy Authority has prepared a strategy to raise the contribution of the renewable energy in the energy balance. About 10% up to 2020 will be from renewable energy source according to this strategy. This comes from PVs, from solar power plants, solar power plants, biogas, and wind farms. Around the world, many studies actually have been accomplished studying and analyzing renewable hybrid energy systems. For the Palestinian case, actually, number of studies have been analyzed stand-alone hybrid energy systems with diesel generator as backup sources. Here we have to take into account the microturbine as a backup source and to make a comparison between using diesel generator as a backup source and microturbines as backup sources. In addition, to analyze various configurations of hybrid systems as we will see. In this study, microturbines as well as diesel generators, as I said, will be analyzed. We have to go through some of the issues that we need in this presentation. The hybrid system is the system that composed of more than one energy source, maybe renewable or traditional sources. Microturbines are relatively new distributed generation technology. Their outputs are ranging from 25 kilowatt to 500 kilowatts. Actually, they are small gas turbines. Microturbines can produce, this is one of the benefits from microturbines, can produce both heat and electricity on a relatively small scale. Here is a block diagram of the microturbine. this is the inlet air, goes to the compressor, compressed, heated, go to the combustor, and then to the turbine in order to obtain a motion, in order to move the alternator, the generator, in order to produce electricity. At the same time, we have a recuperator that we can use it in order to obtain heat. Microturbines here are some of the benefits of the microturbines in comparison with other sources, with other energy sources, as diesel generator. They have long lifetime, about 45,000 hours, lightweight and small size, a small number of moving parts, and this is which makes more reliable than other energy sources. Fast response, high efficiency, low emissions, high fuel flexibility. Compared to diesel generator, microturbines have more fuel flexibility, and it can use more than one fuel to operate it. More reliability, as it contains less number of moving parts, less maintenance, less noise, and less pollution. And this is what makes it beneficial with respect to diesel generator. Microturbines are well suited for small commercial buildings, as small offices, restaurants, retail stores, and other applications. Here we have to go through the modeling of the components constructing the hybrid system. We have, firstly, we have to go through the microturbine. We need to model the fuel consumption of the microturbine. It found that the relation between the fuel needed and the power generated by the microturbine is about linear relationship. And this is the model used that that make a relation between the fuel consumption and the power generated by the microturbine. Here, for the photovoltaic, actually we need the relation that gives the output power generated from the PV panels. Here, the output power actually depends on the solar radiation and the temperature, and here are some of the equations used in the analysis. For the wind turbine, actually, because in our system we have to use as renewable sources PV and wind turbine. For the wind turbine, we have to make a relation between the wind speed and the power generated by the wind turbine. Actually, there are different models used for this purpose, but the commonly used model, which is presented here, gives the relation between the the output power from the wind turbine and the velocity, the wind speed. It is a cubic relationship, and it can given in this relation. Here we have to go through some of the expressions used in the wind turbine. It is the cut-in speed, the cut-off speed, the rated speed here, and the rated power, and all of these are given in this graph. Actually, we have to correlate the power generated from the wind turbine with the height of the wind turbine, because the measurements of the wind speed are measured or are given or are taken at certain height. So we have to correlate this wind speed at the head of the wind turbine. So this is the relation that make this correlation and used in the analysis. Actually, for the battery, we have to go through the energy stored in the battery and used in the case of there is no supply from the renewable sources. The capacity of the storing capacity of the battery, it depends on the energy of the load and the number of days that needed from the battery to supply the load without electricity, and the different efficiencies of the battery, and a value called the depth of discharge of the battery. And this is the maximum allowable amount of that we can take from the battery, and in order to make a certain value of the battery without discharge it totally. Here are some of the relations that we need for the different power electronics devices. We need Bidirectional inverter, we need a charge regulator from the PV, charge regulator for the wind turbine, and actually all of these components has an efficiency. So we have to take into account the efficiency in calculating the powers of each of these. Here the block diagram of our hybrid system. It is the solar panels, the wind turbine, the battery for storage. We need actually solar charge regulator for the solar, the PV. We have wind charge regulator for the wind, and we have bidirectional inverter that works in both direction. Change DC to AC, and sometimes change AC that generated from the DC generator or the micro turbine to DC in order to store it in the battery. And we have the load. Sometimes if we have excess energy, so we have to utilize this excess energy, and we have to dump it or use it as if it can be used. Here we have some of the solution inputs. Actually, we need for our analysis the hourly data for the solar radiation and the wind speeds, and for a whole year. Actually, we need for more than 1 year average these values on hourly basis in order to use it in the analysis. Here are some of the graphs that present the average monthly of each of the solar radiation and the wind speed. Here for a Palestinian case, and the wind speed is for Ramallah, and solar radiation also for the Ramallah location. Actually, we need for the analysis the load. As we speak before, that the microturbine can generate heat as well as electricity. So we have to take into account the heat load in addition to the total load. Total load that take into account the electrical load and the heat load, and actually the heat load. So we have to take into account variations for 24 hours and for 1 year. Here are some of other simulation inputs, costs of various components, ratings of various components used in our system, in our hybrid system, and here are the lifetime. All of these quantities are used in the analysis. Here are some of the results obtained. Actually, in this table, we have, in order to obtain the optimized sizes of the PV system and the battery, in order to minimize the cost of energy production, this is the purpose. We have iteratively changed the PV panel size and the battery and find the combination that satisfies this optimization purpose. In our case, we have found that the PV contribution is about 30%, and here the relation that used in order to find the PV contribution at 100%. And this is the battery, actually the battery relation that used in order, we have used as a changing variable here is the autonomy days. As we said, the autonomy days is the period that we have allowed the battery to supply the load without using any source from renewable sources. So we have found that the cost of energy production, the minimum cost of energy production obtained at 30% PV contribution and 0.3 autonomy days, and it is about $0.286 per kilowatt hour. Actually, here are the sizes of the various components used as a result of this analysis, the PV size, the battery size, and the energy generated from different energy sources in our system. Here are the energy produced monthly from each of the energy sources, from the wind, from the PV, from the micro turbine. And here are the costs of various components, initial cost of various components. You can see that the micro turbine and the wind turbine possess the initial cost that is maximum. Here, about the micro turbine gives a value of about 26%, and wind turbine consists about 27% of the initial costs. Here are other scenarios that have analyzed. The main scenario that take into account. The other scenario is the PV battery microturbine without wind. It is $23 per kilowatt hour. PV wind battery diesel using diesel instead of microturbine. We have 0.315. PV battery diesel without wind. It is 0.36, and the other scenarios. If we have taken into account microturbine alone in order to supply the load, it is 0.296. While using diesel generator alone in order to supply the load, it is about 0.699. Taking into account locations far from the grid and the environmental considerations make the implementation of such hybrid systems more acceptable. Actually, if we compare these values with the price of the electricity come from the utility, it is much than this, the value. In Palestine, it's about $0.17, $0.18 per kilowatt hour. While in our system, it's about $0.28 per kilowatt hour. So it is greater than the value. But actually, take into account environmental considerations, remote locations. This system actually will be beneficial than other systems. Moreover, the prices of the hybrid system actually is components decreases with time. So this will encourage more acceptance of these systems in the near future. Thank you very much.
يعطيك العافية دكتور محمود. تحبوا ناخذ سؤالين هلا وبعدين نشوف إذا ضل وقت للأسئلة بعدين. تفضل.